Good morning, everyone. Welcome to another new session. Today, we will talk about lectures 15 to 17 regarding two types of potential energies, and then how to read potential diagrams and find stabilities. And then finally, we will talk about momentum and impulse. Okay. So in lecture 15, we will discuss about the gravitational potential energy, one kind of potential energy. So there's multiple kinds of this potential energy, but only two will be discussed for Physics 71. It's the gravitational potential energy, and for lecture 16, there's a elastic potential energy. Okay? So gravitational potential energy, or GPE, uh, is the potential energy done, of course, by gravity. And there's a work done. We can calculate the work done by the gravitation or gravity on any object as long as this gravitational energy or this gravity is a uniform force. Okay. And then we will apply some conservation theorems, specifically with mechanical energy, to analyze motions of an objects. Okay. So here we will see that using energy conservations, using these conservation theorems, it will be easier to solve mechanical problems. And then we aim to differentiate between conservative and non-conservative forces. Okay. So which a force is conservative if the work done by the force conserves the energy. Okay. If not, then it's not a conservative force. Okay. So now let's formally define gravitational potential energy, denoted by U sub grav. Okay. So first, the GPE is height dependent because its formula is just m times g times y. So the mass times the gravitational force or acceleration, g, and then the height of an object relative to the source of gravity. So that's y. Okay. Usually, when we are near the Earth's surface, right? If we are near the Earth's surface, then we assume that we can make it as a reference where y equals 0. Okay. So that's the usual case, usually. It makes your life easier. It makes calculations easier if yung isang y ay 0, right? Yun yung reference na. So here, if y is equal to 0, then we also set u equals 0. Kasi if you put y equals 0 here, then the potential energy there is 0. So usually, yan yung isang magandang reference point, right? So previously, tayo nagsaset ng coordinate axis, right? So ito rin, tayo din yung pwedeng set ng ating coordinate axis. So pwede tayo mag-set ng reference points or reference potentials anywhere. And then the work done by gravity is just the negative change in the gravitational potential energy. Okay. So here, if we set this is y equals 0, or hindi, kahit hindi mo na natin iset. So try mo na natin to. So yung potential energy here at the top will be U grav equals m g times y2, right? And then the potential energy at the bottom, so y1, kapag drinap mo na yung ball, will be, sabihin natin to ay top, ug bottom equals m g y1. Okay? And so the work done by the gravity for this ball to be dropped is the negative change in u grav. So that's negative change. So that is final minus initial. So ang final is this one kasi nag-drop siya. So mg minus mg Y1, ay wala pa pala yan, minus mg mg y2. Okay. So then, it's equal to negative, lalabas yung mg, negative mg. We have y1 minus y2. Okay. So this is the work done by gravity if the ball is dropped. Okay, if the ball is dropped. Okay, if the ball is dropped. Ngayon, what if the ball is thrown upward? So if it's thrown upward, baliktad naman. So ito na ngayon yung magiging final, ito yung magiging initial. So meron ka namang negative change in gravity. Mg y2, yun yung final, minus yung initial mg y1, which is negative, lalabas yung mg y2 minus y1. Okay. So makita nyo, nagpalit lang itong term dito. So this again depends on ano yung final state at ano yung initial state ng problem. So if the ball is dropped, ang final state mo ay y1. So dapat meron kang y1 minus y2. If the ball is thrown upwards, then ang final state mo is y2. And we will have this equation. Okay? So remember that. Keep in mind kung ano yung final state ng system. Imagine niyo ano yung final state ng system at initial state ng system. When we do conservation theories and work, when we calculate work. If, important yon, very important, yung definition ng initial and final states. Okay. Okay. Now we apply some conservation, specifically of mechanical energy. So, in our case, since gravitational potential energy pa lang yung alam natin, i-assume natin na yun lang yung only force that does work on the system. Okay. So the conservation of energy requires that the initial energy E1 is equal to the final energy of the system E2. Okay. So energy, so dapat yung energy ng system initially is always equal to the energy ng system at the final state. Okay, yun yung conservation. Kaya sinasabing conserve yung energy, wala naman nadagdag or nabawas sa energy. Kung ano yung energy niya sa start, yun din yung energy niya sa dulo. Kahit na nagkaroon ka ng motion. So that's the conservation theorem. Okay. So anything na conserve, ibig sabihin, hindi nagbago yung quantity na yun. Kahit na mayroon kang binago sa system. Okay. Now, I assume na we learned from high school that, or at least from other sources, na energy is usually written as K plus U. Okay. So total energy is usually written as K plus U. Okay. Okay. Where K is the kinetic energy and U is the potential energy. Okay. But now, we formally, paano ba to? Usually yung kinetic, ito yung associated with the motion, right? So alam natin yan. Pero yung potential, yung isa sa mga usually misunderstood na energy. Okay. So far, since gravity lang yung kino-consider pa lang natin, then we just have GPE, the gravitational potential energy for RU. So E1, yung initial energy will just be K1 plus U1, UG1. Kung force of gravity lang yung mayroon sa problem. Okay? That's why ito yun. Okay? So, and then sa final state, E2, meron ka namang K2 plus U grav 2. Okay. So again, general form lagi ng total energy is K plus U. So you have to identify all kinetic energies present and then all potential energies present. Mamaya may kita natin na yung potential energy, kapag meron na tayong elastic potential, it will just be plus UL1. Ito, magkakaroon ka ng plus UL2. So, addition lang siya. I-add nyo lang ng i-add lahat ng potential and lahat ng kinetic for each of those states. Initial state and final state nung problem. Okay. So, ganun siya. So, if the force of gravity, kapag yung nagpe-play lang sa system natin ay force of gravity, then yung mechanical energy natin is just U graph. K plus U graph. Okay. K plus GP. Okay. Okay, so let's differentiate again. Potential energy, maraming types to. And these are energies associated with position and configuration of the system. Kaya important kung ano yung final at yung initial. Okay? So dapat alam mo yung configuration not just spatially, yung X and Y, but also temporally. Kailangan alam mo yung configuration niya at t equals 0 and at t equals sometime t equals 1 second or 5 seconds. Okay. So, usually naman, ang mga problems is, halimbawa, tinanong sa inyo, ano yung maximum height? E di, maisip mo na ano yung pwede mong ilagay na equation sa maximum height. Right? So, Vmax, ay mayroon kang Ymax, and then if projectile siya, then Vmax equals 0 kasi yun yung maximum height. Diba? So, yun. So, these energy theorems or uh, energy equations is another way to solve motions, right? Not just the kinematic equations na na-learn natin from previous lectures. Right? So, for example, here, meron kang box and then drain up siya. Okay? If drain up siya, then you have y final minus y initial. Yan yung delta y or change in y. Change in the position. Okay, so again, important kung ano yung final. So, yung final or initial, tama pala. Ano ba to? Ay, basta important yung final and yung initial. So, kung drain up siya, then that should read as yi minus y. Ay, joke lang. Hindi, laging yf minus y. Pero y0, ito yun. Y bottom na lang. Minus y top. Kung drain up siya. Okay. If umakyat naman siya, then yung yf minus yi mo is just y top minus y bottom. Okay. So, yung final, tas yung initial state. So, important palagi. Okay? Now, kinetic energy is the energy associated naman with the motion. Okay. So, yung potential energy, yes, may change in y ka. Pero kasi, tinitingnan mo na is yung state, final state, right? Final state ng object at the start and final state ng object at the end. So, stable na siya, right? Ano yung position and configuration niya dyan? Ano yung position and configuration niya dyan? Okay. Yung kinetic energy naman, yan yung energy associated habang bumabagsak or umaakyat yung object. Okay? Kaya yung usual kinetic energy natin na equation is 1/2 mv squared. 1/2 mv squared. Right? It's dependent on the velocity of the object. And this velocity is instantaneous. So instantaneously, pwedeng magbago yung kinetic energy. But the potential energy is usually defined, mas magandang i-calculate mo yung potential energy at the final state and at the initial state, but not across this instantaneous. May usually, minsan mahirap kasi i-calculate yung potential energy habang nagmo-move yung object. So, madali siyang makalculate kapag nakatigil na yung object or alam mo yung initial and final state. Okay. So, yun yung difference. Okay. Okay, now we go to formally define conservation of mechanical energy. So again, conserve yung energy means yung initial energy equals sa final energy. Okay. So if ganun yun, if ito yung nakuha natin from earlier, right? E1 equals E2, then the change in the total energy, which is E2 minus E1, right? Should be 0. Bakit? I-transpose lang natin to. E2, E1. Diba? From this equation, transpose natin yung E1 doon, magkakaroon ka ng minus E1. Tapos ito, 0 na lang. Right? Try natin. Okay. Clear. So from here, transpose natin yung E1 sa kabila. So magkakaroon ka ng 0 equals E2 minus E1. And then, this now, E2 minus E1 is the change in energy. Kasi yan yung final minus initial. So that's your delta E. Change in total energy. And so, alam mo na dapat yung change in total energy of the system should be 0. Right? And this is now yung nandun. Okay. So, interchangeable itong dalawa. Interchangeable yan. You can derive one from one another. Okay. And yung formula for energy, is usually, or yung definition ng energy is K plus U. Kinetic plus potential. So, initial kinetic plus initial potential should be equal to the final kinetic and final potential. Okay. And the work done on the system kapag general case is just a negative change in U. Okay. Negative. So, ito ay general formula for any system or any system na may mechanical energy. Okay. Now, kung meron kang non-conservative force, ito ay for conservative force usually din. Okay. Kung meron kang non-conservative force, kaya siya sinatawag na non-conservative force, it's a force that makes the mechanical energy non-conservative. So, ibig sabihin, kung before, ang conservation natin ay delta E equals 0, ngayon, meron kang in-apply na force sa system such that hindi na siya 0. So, yung change in energy mo, hindi na equal sa 0. So, if we expand this, delta E is E2 minus E1 from earlier, hindi na siya equal to 0. And usually, it's greater than 0. Okay. So, pwede ring less than, depende sa ano yung final initial. As long as hindi siya equal sa 0. So, lagay na natin yung general case. Okay. And saan siya equal? So, ano ngayon yung makukuha mo sa E2 na minus E1? Dapat hindi siya 0. So, may value siya dapat. Yung value na yun, usually, ito yung work other. Ibig sabihin, ito yung work done by that force. Kung ano man yung force na in-apply mo para maging non-conservative yung energy. Right? Yun yung magiging final energy ng change in energy sa system. Okay. So, yung potential energy ay yung gravitational potential energy or GPE, conservative force siya. Okay, nagpapa-conserve siya ng energy. Okay. So, ano ba yung examples ng non-conservative? One is friction. Friction is a non-conservative force kasi some of those energy during the motion is converted into something else. Right? So, kaya nga, yung definition of friction is, it opposes the motion, the direction of the motion. Right? Since ayaw niyang gumalaw yung object, as usually, diba? Or pinapastop niya. So, yun yung yun yung role ng friction. And so, kapag in-apply mo siya sa conservation of mechanical energy, nagkakaroon ka na ngayon ng inconsistencies. Right? Hindi na siya conserved. Kaya din usually ginagawa natin na friction is sa problems, diba? Friction is negligible para maging conserve yung energy, para mas madali mag-calculate. But if friction is present, then we have this change in energy. Okay. Ito yung delta E. So, yun lang yung case. Ito ay conservative forces. Ito ay non-conservative forces. Usually kapag may friction. Okay. So, we have to calculate this work done by the friction. Mamaya malalearn natin how do we calculate it. Okay. For now, let's have an example. Okay, or exercise. Brimstone is standing on a particular location, rafters, okay, to throw his incendiary grenade to the bomb site entrance, preventing the enemies to push through. Okay. He fired his grenade at an angle of 60 degrees with an initial velocity of 16 meters per second. If the rafters is 1.5 meters high, how high above the height of rafters the ball rises? And what is its speed just before it hits the ground? Okay. So usually it's good to um, draw again the problem, right? So sabi dito, meron kang rafters na 1.5 meters high. So let's draw that. So ito yun. So this is the rafters. Yeah, so this is 1.5 meters. Yeah. And then si Brimstone nandun daw sa taas. But he fired an incendiary at an angle of 60 degrees. So meron kang 60 degrees, right? Then nag-fire siya ng incendiary grenade to somewhere else. Okay. Ngayon ang tanong, how high above the height of rafters the ball rises? So actually, hindi ito ang tanong diyan, how high above the rafters, right? So kung ito yung dulo ng rafters, right? Ito yung top ng rafters. Tinatanong na height ay this one. Hindi kasama yung nasa baba. Okay, hindi kasama ito nasa baba. Kasi above the rafters lang. Okay. Okay. So yung dito, pwede nating isipin na yung initial state ay yung nandito sa yung incendiary ay nasa taas. Okay. So this is the initial state, yung this one. And then the final state is yung ito, yung maximum height. To answer the first question. Okay? To answer the first question. So if this is the initial, this is the final. Okay. So using conservation of mechanical energy, we have E initial equals E at the top. Ito yung how far the ball rises. That's the top. And then delta E, E mech is K plus U. Right? K plus U. Since this is a somewhat a projectile motion, so alam natin na yung only energy or only potential energy working or only force working is the gravitational force. Yung weight lang yung nag-work dun sa incendiary. Right? Assuming walang air resistance or wala kang air drag. So with that, pwede nating isulat na yung potential energy is just caused by gravitational potential energy. So that's just mgy for initial and the final state. Okay. So, meron din tayong initial kinetic and initial potential. So, K1 plus U1 equals K2 plus U2. And yung initial kinetic natin is 1/2 mvi squared. Okay. Then yung initial potential energy natin is mgy sub I. And then yung final na kinetic is 1/2 mv squared top. And then U2 is mgy top. Okay. Okay ba yan? Now, since we are free to set wherever yung U equals 0, kung saan natin gustong initialize yung potential energy, we can set that here sa sige, ang dami na nating drawing. Yan. Yeah. We can set y equals 0 here. Bakit? Kasi hindi naman natin kailangan to, right? Hindi naman natin kailangan to talaga. For the first question. Okay. So we can set here, ito yung coordinate axis natin. So that's y equals 0 and x equals 0. And then that's also where u equals 0. So again, if y equals 0 on the top of the rafters, right? If y equals 0, then this will be 0. Now, stronger. Then this will be 0. And so, yung mg0 to mawawala na. So, meron ka na lang 1/2 mvi squared plus 0. So, this is 0. Okay. Okay ba yan? Now, for the v-top, so again, this v-top should be a magnitude of the velocity at the top. So remember, velocity here is instantaneously, kapag projectile, vector naman talaga yan. Meron kang Vx and Vy. Okay. So meron kang Vx and Vy. So, sulat natin. V equals Vx I hat plus Vy j hat. So meron kang Vx and Vy. Where Vx is V naught cosine theta, right? Alam natin na this is V naught cosine theta. For this case, yung theta naman natin is nandito, 60 degrees. Okay. I-ano ko na lang. Pakita ko. So, meron kang Vx and Vy. Since ito yung theta, so magta-triangle ano ulit tayo. Yung theta, right? Yung 60 degrees. So, gusto natin malaman, ito yung V. So, this is a Vx, yung x component. And this is Vy. So, to get the x component, so we use SOHCAHTOA or specifically cosine. Cosine theta equals adjacent, yung katabi, over hypotenuse, V. Okay. So that's why Vx is V cosine theta. So this is actually V naught yan. V. So V naught cosine theta plus I hat yan. I hat. Tapos yung Vy mo naman yung Vy. V naught sine theta. Okay. So yun yun. Now, kailangan lang natin dito ay magnitude ng vector na velocity. Okay, since V yan, wala namang arrow yan sa taas, so dapat magnitude. So again, paano kinukuha yung magnitude ng vector? So magnitude of the vector is equal to square root ng Vx squared plus Vy squared. So para siyang Euclidean distance. Kaya pag nag-calculate kayo ng Euclidean distance sa geometry is just para ka lang nag-Pythagorean theorem, right? Or c squared equals a squared plus b squared. So similar din dito kasi ito nga yung ano na yan, v, vy, vx. Right? So nag-Pythagorean ka dyan, so this is v squared equals vx squared plus vy squared. So yun yung ginawa mo dito. Again, v squared equals vx squared plus vy squared. But you just want the velocity. You just want the magnitude. So magkakaroon ka ngayon ng square root para matanggal yung square. Okay. Kaya natin nakuha tong equation. Okay. From that, we know that in the projectile, ang Vy at the maximum height is 0. Okay? So maximum height yan. So dapat Vy dito ay 0. So matitira ka na lang ng square root ng Vx squared. So magka-cancel naman yung square root sa kanyang squared. So matitira ka na lang talaga is Vx. And Vx from our SOHCAHTOA we know is V naught cosine theta. Okay, V naught cosine theta. So again, magnitude yung V top is magnitude ng V at the top. Since ang V mo ay dalawang components, meron kang Vx and Vy, so you have to decompose first. But then, alam natin na yung Vy sa taas ay 0. Kaya mawawala yung Vy na to. Matitira na lang tayo ng Vx, which is just V naught cosine theta. Okay. Okay. So let me clear all all drawings. Sige, okay na yan. So ito, nakita natin na nag-zero to, right? Nag-zero yan. This is just, yung V-top dito is just V naught cosine theta. Right? So if we plug in, makukuha natin is something like this. Okay. So bakit nawala yung M? Kasi lahat ng terms may M. So pwede mo mag-cancel ng M. Okay. Sige, pakita ko na lang. From here, nag-zero. So yung lalabas na sagot ay 1/2 mvi squared equals 1/2 m v top ay vi cosine theta squared, right, plus mg y top. So again, lahat ay may m. Lahat ng terms may m. So pag divide ka ng m on one side, pwede ka magdi-divide ka rin ng m on the other side. Magka-cancel lahat ng m. So you will left with this. Okay? Okay ba yan? Now, we can now plug in our values. Alam natin yung VI, that's 16 meters per second. Alam natin yung theta, which is 60 degrees. And then, alam natin yung, hinahanap natin is Y top. Alam natin din yung G. Take note, if you can see, hindi naman natin kailangan ng mass. Hindi natin kailangan malaman yung mass kasi nag-cancel out siya. So, kahit may given tayong mass dito, hindi rin natin siya magagamit. And remember, itong ano na to, given na to, hindi rin natin kailangan gamitin. Kasi sinet na natin yung initial state to be at the top of the rafters. Okay? So, kailangan lang talaga natin for the first question is this and this. Yan. So, kung isosolve mo to using kinematic equations, dapat alam mo yung mass, right? Kasi meron kang y equals x sub t. Actually, hindi rin pala. Kasi y equals y naught plus v naught t minus 1/2 gt squared. Yung kinematic equation for the projectile, hindi rin kailangan ng mass. So, essentially, hindi mo rin talaga kailangan ng mass. But here, ni-skip na natin yung any difficulty in solving a possible quadratic equation kasi hindi natin alam yung time, di ba? So, kailangan natin malaman yung time sa projectile, t squared. Ito, hindi na natin kailangan. We just need the initial and the final state of the system. Okay? So, if we plug in now those values, we get the following value for the y top. Okay. So again, isolate mo yung y top. So 1/2. To ay mapupunta sa kabila. And then divided by g. So that's why you get this. Okay. Now, what is its speed just before it hits the ground? So ano ngayon yung v just before it hits the ground? So drawing ulit natin yung system. So, meron kang rafters. Merong height yan, 1.5. Sabihin natin h. Nandito yung si Brimstone. And then nag-fire siya ng molly, 60 degrees. Back. Okay. So ngayon, ano yung ngayon yung speed here? Okay? Just before it hits the ground. So dito, kailangan na natin siguro yung h. Okay? So again, let's set ano yung initial, ano yung final. Okay? So again, free ka to choose whatever yung initial and yung final. So here, pwede nating i-choose na yung initial state, syempre nandito pa rin siya, and then the final state would be here. Right? Okay. initial state and then final state. And then if we choose that state and retain yung coordinates natin kanina, so yung coordinate natin kanina is this, di ba? So ginawa natin na this is y equals 0 and u equals 0. Yun yung reference potential natin. Okay. So ano ngayon yung YF? Okay, sige, ito muna. Pwede nating set na ganyan. And so if we use the conservation of mechanical energy, E mech I and E mech F, again, i-write natin yung K plus U initially and finally, and the final state. So 1/2 mv squared and mgy, ganun din sa final state. Ngayon, alam mo yung VI, again, this is, nakuha na natin kanina yan. Right? Yung initial. Yung mgyi ngayon, with that, with this, is ito. So, mgyi, again, 0. Kasi sinet natin na yan yung 0, yung initial na y. Right? 1/2 mvf squared, vf yung hinahanap, final velocity. Ngayon, for the mgyf, ano ngayon yung final height dapat? So that should be negative 1.5 meters. Bakit? Kasi nasa baba siya nito. So alam natin yung height ay 1.5 right, meters. Tapos yung v na to, yung final state is below dun sa reference natin. So that is negative. Okay? So again, this is due to our choice of coordinate axis. Question, what if ang ginawa ko, sir, sinet ko na yung 0 ay yung nasa baba. So, di pala. What if ganito, sir? Ito. So, sinet ko na to yung 0. U equals 0. Okay lang yan, actually. Right? Pag ganyan yung project. Okay naman yan. Magpapalit-palit lang yung mga signs mo or mag-a-add ka lang ng something in the magnitude dun sa ibang variables. For example, if this is the case, then yung YF mo dyan, right, is 0, pero yung YI mo is not anymore 0. It should be 1.5. So you can see, right, yung effect niya. So if this is minus 1.5, if we use this YF plus minus 1.5, so dito yung may minus 1.5, ito 0. Okay. Kapag ganito naman yung choice mo, if this is your choice, then ito yung 0, ito yung plus 1.5. But then, if we transpose it to the other side, magiging minus 1.5 pa rin. So, it doesn't matter kung ano yung reference mo as long as consistent. As long as consistent yung choice of coordinate, kung saan mo sinaset yung u equals 0 or y equals 0, magiging consistent yung pag-solve mo ng conservation of energy. So, and same lang yun. Okay, it's all in the choice of the coordinates. So, be careful with that. Okay. Okay. So, in our case, sinet natin na yung y equals 0 ay na kay brimstone sa taas ng rafters. That's why we get this YF. Okay. So, again, you have this equation. Yi is 0. So, mawawala yan. Tapos, meron ka mga m na magka-cancel, cancel, cancel, cancel. And we are left with this equation. Okay. And we aim to find VF. So, VF, i-isolate natin. You get this, right? So, with this VF, meron kang 1/2 VI squared minus GYF. Tapos, mag-multiply ng 2 and then take the square root. And then, pag sinimplify mo, you will get this. Okay. And then, plug in our values. VI is 16 meter per second squared. Meron kang G, and then meron kang yung YF, which is negative 1.5, and you get this final velocity. Okay. Question, bakit VI to walang cosine 60 or sine 60? Kasi initially, wala ka pa namang angle, right? So, sa initial state, hawak pa lang ni Brimstone yung molly, right? Or yung grenade niya. So, wala talaga tong angle. Pero, kapag tumapon na yon, yung instantaneous velocity, yung v of t ngayon, here, across this, v of t here, is a function of that v naught. So, dito nalalabas yung vx I hat plus vyj hat. Okay? So, yung sinasolve natin sa projectile, yung vx I hat plus vyj hat, ay yung function of velocity over time. Hindi kasama yung initial. Well, pag sinama may initial, sa initial, wala naman siyang wala siyang angle kasi hindi pa siya na-release. So, that's just cosine 0 is 1. Okay. So, that's we have 16 lang dito. Okay? Sa initial state. Kasi ito yung initial state. Kapag yung final state mo is somewhere along this line, yun yung magkakaroon ka ng ganito. Sa initial state, VI lang siya. V0 lang talaga siya. Okay. Okay. Let's go to a second type of potential energy, which is the elastic potential energy. And this is present to any spring mass systems. Okay? So kapag meron kang spring, usually common yan sa engineering and architecture ng buildings, you need to calculate for the elastic potential energy. And then we aim to apply, again, the conservation of mechanical energy for the spring mass systems and apply conservation for systems subjected to both the spring force and the uniform gravitational force. Okay. So now we define elastic potential energy to be 1/2 kx squared, where k is the elastic coefficient of the spring. So yung coefficient of the spring. Okay. And then x is the distance compressed or stretched by the spring. Okay. So yan yung kx squared. And yung work energy theorem natin is just total energy is k plus u, where u is u elastic, right? Which is just this. Final equals the initial energy theorem. So again, this is only true if EPE lang yung present. Okay? Kapag meron kang elastic potential plus GPE, so ano mangyayari? Mag-a-add ka lang ulit dito ng mg y1 plus mg y2. Okay? So kapag combination na siya ng both. So remember, laging E equals K plus U. E equals K plus U, where U is the total potential energy. So kung dalawa yung potential energy mo, elastic sa gravitational, then you have this term, both of these terms. Kapag purely elastic, then you just have this. Okay. So remember, yung conservation of mechanical energy is the total kinetic plus total potential. Okay. Example. A 2 kilogram block is pushed against a spring with a negligible mass and force. Ang force constant or yung spring constant is K equals 400 newtons per meter. And compressing the mass with a 0.22 meters. So yun yung length of compression. When the block is released, so ito yung mass, right? Ito yung spring. Ngayon, pinush natin yung block, right? So that mako-compress yung tawag dito, spring by 0.22 meters. Mako-compress yung spring. Okay. When the block is released, it moves along a frictionless horizontal surface. So, move daw siya pa ganito. And then up a frictionless incline with the slope 37 degrees. So, parang ka na ganon, and then, so parang pinball. ang tanong, how high does the block travel up the incline before starting to slide back down? So ano ngayon yung maximum height na marireach ng block bago siya bumalik pababa? Okay. So ito na yung drawing, right? Yan yung drawing. So ano yung mga kailangan natin i-take into account? Okay. So first, at maximum compression, yung initial state, ito ngayon yung initial state natin. Okay. Yung maximum compression, yun yung kinompress natin. So here we can set that y1 is 0. So again, this is our tawag dito, coordinate axis. So ang y dito equals 0. So dito natin set yung u equals 0 on this line, right? So y1 equals 0 there. And then x1, ito yun, is 0.22 meters. Oh, yan yung compression. Okay, times the mass. Ay, hindi, meters pala. 0.22 meters. And then, in-stabilize natin, so steady lang muna, so that V1 equals 0. So, pinush natin para makompress. Pero yung compress na yun yung maximum compression na yun yung initial state natin. So, within that case, wala tayong V. Wala tayong velocity. So, V1 equals 0. Okay. Ngayon, yung final state natin na gustong malaman is yung nasa taas na siya. How high here? Okay, dito na lang. Yan. How high siya na mapupunta. So ito yung initial state. Ito yung initial state. Ito yung final state. So at final state, meron tayong maximum elevation. So ano naman yung property sa maximum elevation? Hindi natin alam yung height, of course. But we can set the x here, yung x2 to be 0. Bakit? Again, this x1, x2 ay yung sa elastic potential energy. So remember, UL equals 1/2 kx squared. Right? Where x here is yung compression ng spring. Okay, so sa start, may compression yung spring na 0.22 meters. Sa final state, wala nang compression yung string kasi na-release mo na yung object. So fully stretched na ulit yung, ay fully equilibrium na ulit yung spring. So there, x2 equals 0. Okay, and again, ito ay maximum height. Bago siya mag-slide back down. Okay, so sa maximum height, again, kapag nag-change ka ng direction, kapag yung object nag-change ng direction from upwards to downwards or upwards to downwards, yung V at that moment or at that instant is 0. That's why yung V final natin is 0. Okay. Kasi yung question, before it comes back down, pag wala yun, edi wala tayong ma-assume about the final velocity. Okay? So that's it. And now we can now apply conservation of mechanical energy. So again, E initial equals E final. And now, may dalawa tayong forces in play. Yung gravitational potential energy, yung weight, or gravitational force working on the weight of the object, and yung elastic potential energy, UL. Okay? So, again, walang friction kasi ngayon na-assume natin na frictionless yung surface saka yung incline. Okay. So, initial kinetic energy, 1/2 mv squared. So, V there is 0. V is 0. So, kaya magsi-0 to. U graph, sinet natin na 0 yung y initial. So, magsi-0 din to. So, mgy, right, is 0. Pero meron tayong elastic potential there, which is 1/2 kx1 squared. Okay. So, final state, again, V equals 0 there. kasi yan yung moment na bago siya mag-slide back down. So, 0 yan, final. Meron tayong mgy2, right? Hinahanap natin yung maximum height. Pero wala na tayong elastic potential energy kasi hindi na siya in contact with the spring. Hindi na naka-stretch or compressed yung spring. So, 0 na to. Again, x2 there is 0. Okay, so we are left with these two terms. Okay, and then we now apply or plug in our values. So, and then isolate y2. So, para ma-isolate sa y2, di-divide ka lang ng mg. So, kx1 squared over 2mg. And then plug in our values, 400, 0.22 squared, 9.81, and then 2 kilograms for the mass. And we get the maximum height. Again, this only works if the incline is frictionless, as well as if we are considering the maximum height. Okay? So what if the incline is not frictionless? So magkakaroon ka na ng work done by the friction. So magiging ganito lang siya, work others. So mag-a-add ka lang ng work others on one side of the equation. Okay? Actually, mali ito dapat. Dapat yung work others ay nasa final state. Kasi kung yung incline yung may friction, then dapat sa final state merong friction. Okay. Kung ang surface mo may friction din, kung ito ay may friction din, then okay lang to. So meron kang work done by the friction of the surface. Then sa dulo, meron kang work done by the incline. Okay. Kung magkaiba yung friction nito sa friction nito. So again, ayun. Kung same lang, tapos parehas percent, edi equal lang yung dalawang terms nila. Pero percent sila. And again, mas mahirap i-solve yan. So, hirap i-solve yan usually. Okay. And yun nga, minsan hindi equal yun. So, yan yung nagpapa non-conserve dun sa energy, sa mechanical energy. Okay. So, another conceptual exercise. An object hangs motionless from a spring. When the object is pulled down, what happens to the sum of elastic potential energy of the spring and the gravitational potential energy of the object and Earth? Okay. So again, meron tayong spring, and then meron kang object na nakahang motionless. But then you pulled it down. So what happens to the sum of the potential energy from the spring and the gravity? Okay. So again, initially, yung UI mo is this state. So UI there is just the weight, the gravitational potential energy, right? mgy1. Bakit? Kasi motionless. So wala ka namang compression or anything from here. Walang work na ginagawa si spring from that case. Okay. Pero yung U final mo, so meron ka pa ring mgy1, yung weight, mgy2 na siya. And then, meron kang elastic potential. Bakit? Kasi nag-stretch to. Okay. Nag-stretch yung spring mo. So, meron ka ng 1/2 kx squared. Okay? So, what happens? It will definitely increase because of this compression. Okay? So, since a force is needed, this is required to move the object downwards. Again, pinull down mo siya. So, meron kang external force. Then, work is done on it. Meron kang work others pa. Right? Done on the system. Then, this work done should be stored as the elastic potential energy. Okay. So yung 1/2 kx squared mo, manggagaling dun sa force na ginamit mo to pull down the object. That's why mag-i-increase yung total potential energy. Okay. Now let's go on analyzing potential diagrams or potential functions and stabilities. Okay. So this will be important in physics 72, for example. Kasi in physics, in electromagnetism, you need to know the potential at each point on the field and then evaluate the stability there if attractor siya or stable, unstable equilibrium or neutral equilibrium. Okay. Okay, so recall the work done by any conservative force is just the negative change in the potential, mechanical potential energy. Okay. So yung work equals negative del U, delta U. So again, delta means change in the mechanical energy. But work can also be calculated using the dot product of the force and the distance traveled. Okay. So again, if meron kang object, you apply a force, and then this object moves or may displacement na S, right? Then the work done by your force, by this force, is F dot X. Okay. In a component form, that will be F, and then yung displacement ni S is delta X cosine theta. So that product is just the magnitude of F, magnitude of S, cosine theta. But then our theta here is should be the angle between the force and the S. Pero ano yung angle between sa kanila? 0 degrees. Right? Kasi parallel sila. So cosine 0 should be 1. Kaya we are just left with this formula or for this equation. Fx delta x. Okay, so this is the magnitude of the work done by that conservative force F, or by any force F actually. And then if we want to find the potential energy from the force, we can use derivatives or differentiation. So hopefully na-tackle nyo na to sa Math 21 about derivatives. Don't worry, medyo simple lang naman yung derivatives na gagawin natin here. So just remember na any conservative force, right, is equal to the negative derivative of the potential. So ito yung derivative of the potential. Okay. Kapag one dimension, so ito yung gagamitin natin. Kapag 2 dimensions or 3 dimensions, then you have this negative del U, where this del, inverted triangle, is the gradient. Okay. So gradient yan. For example, yung F natin, meron kang Fx I hat plus Fy j hat. Okay. So, yan yung force natin, dalawang direction. So yung negative del U is just the gradient or the derivative of the sum of the components. Or sum of the derivative of the components. So meron kang negative derivative ni U over dx I hat plus derivative ni U dy j hat. Okay? So, para ka lang nag-sum ng mga ganito sa loob, yun lang yung ibig sabihin ng gradient. Okay? Per component yan. Okay? Per component. Okay? So, yan yung gradient. Okay. Now, we analyze yung potential functions or potential diagrams and force diagrams. Okay. For the gravitational potential energy, so here we have on the left is the potential diagram. So this is U versus the direction Y or the position Y. Okay. So since yung U naman natin, function lang siya ng Y, mgy lang siya. And linear yan, so we expect a linear trend for this function. So what we can see here, if as the potential energy decreases, as Y decreases, pag bumaba si Y, bababa rin si U. Ito yung point na yon. Okay? Kapag naman nag-increase si Y, mag-i-increase din si U. Okay? Kasi linear lang yan. Linear lang yung gravitational potential energy. Now, we try to find the force done by the gravity. By this potential energy. So again, F equals negative du dy. Kasi Fy lang naman yan. So derivative ng, so equal siya sa negative derivative d dy ng mgy. Okay? So negative derivative ng mgy. So yung m at g constant. So lalabas lang siya sa derivative. And then you will left with dy over dy. And this is just 1. So matitira ka na lang negative mg. That's why this is negative mg. Okay. So if we now try to plot Fy versus Y, so makikita natin, constant lang siya. Okay? Kasi hindi na siya function ng Y. So for any Y, constant lang si Fy, which is negative mg. For all Y, the force is always less than 0. Hence, the force pushes the body towards decreasing Y. Pwede rin itong mag-explain kung bakit nahuhulog yung objects. The force of the gravity always pushes the body towards a lower value or lower height. Kaya, any object na nandyan sa Earth, along the Earth's surface, always tends to go down because of this. Okay. So pag tinanong sa inyo, bakit nahuhulog yung apple? Ayun na yung sagot. Kasi kapag kinuha mo yung force done by the gravitational potential energy, the force always pushes the body towards a lower height. Okay? Now, for the elastic potential energy, so ito naman, recall na yung elastic potential ay U equals 1/2 kx squared. Right? So U equals 1/2 kx squared. Ito pala. Okay. So 1/2 kx squared. So this is a quadratic parabola. So we expect the plot of the potential versus the position x to be this kind of parabola. Okay? Okay. Now, hindi naman usually accessible yung buong equation na yan, because the total energy limits this parabola, right? For example, meron kang spring, right? So yung total energy na pwede mong i-apply or total elastic potential energy na pwedeng ma-apply dito is limited kung ano lang yung maximum distance na to. Right? Hindi mo naman pwedeng ma-stretch yung spring hanggang sa kabilang side, di ba? Hindi pwede to. Hanggang dito lang siya. Or at least, hindi pa nga hanggang 0 eh. Minsan hanggang dito lang. Di ba? Kasi may maximum compression. Right? That's why this limitation is this boundary. E equals K plus U. Okay? Yung motion ng spring is limited where U curve intersects with this horizontal line. Okay? Representing the total mechanical energy. So hanggang dyan lang talaga pwede mong i-apply na energy or na force. So limited yan. Okay? And dito makikita natin yung exchange mismo ng kinetic sa kanang potential. So, kapag meron kang mass dyan na nagwa-wobble-wobble, right? So, pag nagwa-wobble yung mass, nakadikit siya sa spring, then yung energy mo nag-oscillate lang into this parabola. So, nagkakaroon ka ngayon ng interchange ng K and U. So, minsan mataas si K, pagdating dito sa point na to, mataas si U, right? Or mababa si K. Ganon din sa kabilang side. So, yan yung nangyari kapag nagwa-wobble yung spring mass system. Okay. So, yung as it wobbles, again, yung total energy, nag-oscillate lang din dito. Pabalik-balik lang din siya. Okay. Now we have to find the force. So again, this is our elastic potential energy, 1/2 kx squared. So again, ang force ngayon is the derivative. Okay. Dito na lang. So force x equals negative derivative ng 1/2 kx squared. So dx ng 1/2 kx squared. Okay. So 1/2 k, constant yan. 1/2 ay constant. Yung k mo, force coefficient ng spring ay constant. So lalabas ngayon sila. So mayroon ka pa rin negative 1/2 k, or sabihin natin k over 2. Derivative ng x squared over dx. Okay? So in derivative, remember kapag may exponent, yung rule lang dyan is yung derivative ng x to the n, right? Derivative ng x to the n is equal to n times x n minus 1. Okay. Okay. So now, this derivative becomes negative k over 2 times, yung n natin ay 2, so times 2, times x raised to 2 minus 1, which is just 1. Right? So, magka-cancel yung 2, we will have negative kx. And that is why, eto yan. Okay? So, F equals negative kx. So, linear na ngayon si force. Kanina, constant si force for any y, for potential energy. Ngayon, linear naman siya, and ang slope ay pababa kasi negative. Negative yung slope, right? So, linear siya, pababa. So, for x less than 0, Fx is greater, the force is greater than 0. For the force pushes the body towards the x equals 0. Where x equals 0, ito yung tinatawag natin na equilibrium position ng spring. So yan yung kapag relax lang talaga si spring. Hindi siya stretch, hindi siya compressed, hindi rin siya stretch. Yun yung nandito sa origin. Okay? If the x, yung compression is greater than 0, then the force pushes the body again towards the origin. Kasi less than si force. Okay. So the force here tends to push the force on the origin, and then here tends the force back to the origin. Kaya kapag in-stretch mo yung spring, or in-stretch mo or kinumpress mo, magwa-wobble siya until such a point na bumalik siya sa equilibrium. So ganun din dito. Kapag in-increase mo yung energy towards this direction or towards this direction, mag-oscillate siya until ma-reach niya yung lowest potential energy. So yan yung nangyayari sa system. Any system in motion, gusto niya ma-reach yung lowest potential energy, which is this. Same with this. So dito, ang lowest potential energy mo is always on the bottom. Kaya lagi na push downwards naman to, yung direction. Okay? So ito, napupush ka sa origin. Okay, now that we have talked about the equilibrium, so equilibrium happens when all of the net forces is now 0. Like wala talagang force na. So again, this is the point where the potential energy is usually at the lowest. Now, ang tawag doon ay minima. Kasi minsan maraming lowest points yung energy, yung potential energy. So meron kang mga local minimum or minima. Okay? So here, for example, meron tayong ditong plot of the potential energy versus the position X or Y. Right? So meron ka ngayon mga minimum and maximum. And these are local kasi hindi naman sila like the total minimum or the global minimum or global maximum. Okay? So meron kang local minimum dito, local minimum here, local maxima there, local maxima there. Kapag minimum siya, then that means the equilibrium them is stable. Okay. Local minima gives the stable equilibrium points. Yung local maxima, mga ganyan, kung saan nagka-curve downwards, yan naman ay mga unstable equilibrium points. Okay. Neutral yung kapag neutral equilibrium kapag meron ka lang constant potential energy. So for example, yung ganito lang yung UX mo. So this is a neutral constant potential energy. So neutral equilibrium if this is the case. Okay. So again, let's go back to our let's go back before. Ito, so for this, again, ito, sa gravitational potential energy, saan yung local minima? Actually, wala ka talaga local minima kasi laging pwede ito mag-stretch pababa. So, ito lagi yung lowest. Okay? So, kung ano man yung lowest na possible dito, yun yung stable equilibrium. Okay? With this, meron kang isang minimum. And actually, siya rin yung global minimum. It's not just the local, but the global minimum. So, this is a stable equilibrium point for the spring mass system. And yan yung kapag yung spring mo is neither stretch or compressed. Okay? Okay, so let's go back. So ngayon naman, if you try to find the derivative of this potential energy, you get the force, right? And ito yung corresponding force component. Okay? Yan yun, negative du dx. So what we can see here, kung nasan yung mga minima, actually nagiging zero siya nung force. Ibig sabihin siya yung solutions for the force. Okay? So what ang i-remember nyo lang dito is if the force is greater than zero, if the force is greater than zero, if positive, tapos negative yung du dx, right? Then you will reach a stable local minimum. Okay? So sa stable local, again, sa stable equilibrium point, sa left niya, meron kang positive force, so positive force, and negative change in energy. Okay. Sa kanan naman ng stable equilibrium point, meron kang negative force and then positive change in potential energy. So nakikita nyo na nagsiswitch yung signs if you cross the local minimum, the stable point. Okay. So sa unstable naman, baliktad naman. Sa kaliwa niya, negative yung force. Ito yun. Positive yung du dx. Sa kanan, sa right, du dx is negative. And then, positive yung force. Okay. So again, if positive F, this is stable, negative F. So kapag ganyan yung transition. Kapag naman ang transition ay negative to positive force, then meron kang unstable sa gitna. Okay. Kapag constant, force, parehas lang positive or parehas lang negative and hindi nagbabago yung magnitude, then meron kang neutral. Okay? Okay, example. Consider a particle moving along the x-axis. acted upon by a single force. The potential energy is shown in this graph. What is the direction of the force at points A and B? And what is the force at point C? Okay, again, to find the direction, we use this fx equals negative du dx, right? Okay, so recall, the slope is ux is negative. At point A, the slope of ux is negative, right? So yung slope na yun yung du dx. So negative siya dito. So negative yan. So dapat yung negative na to ay lalabas. So yung fx mo is, di ba, negative na yan. Ito na lang pala. So yung force mo negative du dx, pero yung slope mo negative din. So magkakaroon ka ng negative times a negative becomes positive. So the F must be towards the positive direction. So yung force on point A is positive. Okay. So medyo pataas siya. I think pataas. Yeah. Hindi, pababa. Pero positive yung force. Okay. At point B, so ito yung A. At point B, the opposite naman is true. Bakit? Kasi at point B, positive yung slope. Okay, so negative du dx, negative times yung slope, which is some positive number, equals sa negative. So ngayon, yung force dito must be towards the negative direction. Okay. At point C, the slope should be 0 kasi minimum. Ay, maximum siya. Okay, so the force at C must be 0. So again, yung forces on our equilibrium points are 0. Okay. So remember, ito yung mga equilibrium points kung saan yung minimum and maximum. Pag tinignan natin siya sa force plot, siya ay mga 0. So ang force there ay 0. Okay. Now, at what x is the kinetic energy is maximum? So again, remember, kanina sa spring mass system, meron tayong interchange ng k plus u. Right? Maximum ang kinetic energy kapag minimum si lowest si potential energy. And vice versa. So kinetic energy is maximum when the potential energy is minimum. So asan yung mga minimum? Ito at ito. So dalawa yung local minimum mo, right? Pero yung global minimum ay ito lang. Kasi siya yung pinakamababa sa lahat ng mabababa. Okay? So dito, sa point na to, yan yung may pinakamataas na kinetic energy. Okay? So kapag ganito yung tanong, what is the kinetic energy at maximum? Kailangan global maximum and global minimum yung potential energy. So kapag dalawa yung potential energy mo na minimum, kukunin mo lang yung global, which is yung pinakamababa sa lahat ng mababa. Lowest of the lowest. Okay? At what x is the particle in equilibrium and what type are they? So, tatlo yung equilibrium points natin. Right? Tatlo yung equilibrium points, x2, x4, and x5. So, sa x2, meron tayong stable kasi siya ay minimum. Sa x4, meron tayong unstable kasi siya ay maximum. Sa x5, meron din tayong another minimum kaya siya ay stable. Okay. Okay, so next exercise. Given this potential diagram below, at each point indicated, A, B, C, D, E, and F, state whether the x component of the force associated with this function is positive, negative, or zero. And then at which point does the force have the greatest magnitude? Identify the equilibrium points. Okay. So again, for the force, kung positive, negative, or zero, kailangan natin makuha yung slope. Right? So again, force is negative du dx. Right? So sa point A, ano yung slope natin? Pataas. So positive yung slope. So this way becomes positive. Then the force must be negative. Okay? Sa point B, maximum yan. So dapat zero yung force. Sa point C, pababa yung slope. Negative yung slope. So dapat negative times negative. Positive ngayon si force. Point D is a minimum. So zero din yan. Point E, positive yung slope. So yung force mo ay negative. Okay. And sa point F, zero yung slope. Kasi constant lang siya. Okay. Next, at which point does the force have the greatest magnitude? Okay. The force has the greatest magnitude where the slope is steepest. And therefore, siya ay sa C. Ito, yung pinaka-steep na slope. Sa inyo may pinakamataas na biglang change. Okay, so ito pag ganyan. So pwede yung gamitin visually. So ito medyo ganyan. Ito force nito 0, slope niyan 0, slope nito 0. So ito yung may steepest slope na negative. Okay. Negative or positive, basta yung steepest slope, yun yung maximum magnitude of force. Okay. Identify any equilibrium points. So again, meron tayong 3 equilibrium points. Meron tayong maximum, minimum, and a neutral. So sa maximum, this is unstable. Sa minimum, meron tayong stable. And then here, sa constant, meron tayong neutral equilibrium. Okay. Finally, we discuss momentum and impulse. And determine how impulse of the net force acts on the particle and causes the momentum to change. Okay. Okay, so recall from Newton's second law, the net force is equal to mass times acceleration. And then we know that from our kinematic equations, acceleration is the change in the velocity or the slope of the velocity over time. So that's dv dt, right? Ngayon dito, we assume that mass is constant, hindi siya changing as the object moves. So pwede natin ngayon siyang ipasok sa derivative. And then we get the linear momentum. And then we define the linear momentum P equals mv. So this now term here is defined as the linear momentum P. And again, momentum is a vector. Okay, vector siya. So kung gusto mo makuha yung magnitude ni P, kukunin mo rin yung magnitude ni mv. This is just mass, magnitude ni V. Okay. So now we can rewrite the net force to be dp dt, the derivative of the linear momentum P. And actually, this is how Newton originally written his second law. Okay. So yung Newton's second law, hindi naman talaga siya F equals ma originally. It's actually this equation. This is how Newton described the total force. So, kinailangan niya i-invent yung calculus or essentially, kailangan niya ng calculus of his own to make sense of this his Newton's laws or his laws of motion. Okay. So if you want to take the average force applied, then it's just the change in momentum. Delta P over delta T. Di naman kailangan derivative. Ito ay instantaneous derivative. Ito ay change in P and change in T. Okay. For the average. From here, we can now find that the change in the linear momentum is the average force times the delta T. And we define this as the impulse. Okay. So that J vector, the impulse vector is just the change in the linear momentum. Okay. So again, linear momentum, mv equals p. So momentum, you're the real MVP. And I think dito na mag-occur yung may nag-ask before na about dun sa butterfly and truck na 'di ba may truck ka tas may butterfly. So bakit hindi daw tumatalsik? I think it's about the Newton's third law, right? Equal yung force across on each other, equal yung magnitude ng force, pero ba't hindi tumatalsik yung truck kaysa sa butterfly? Again, it's because of this linear momentum. Okay. So kasi si truck, mataas yung V, mataas yung M, mataas din yung velocity. Right? So meron siyang mataas na linear momentum. Ngayon, si butterfly, mas maliit yung mass, mas maliit din yung velocity. So hindi naman niya kaya mag-speed up ng same ng truck, 'di ba? So kaya kapag nag-collide sila, later sa collision, may kita niyo yung kapag nag-conserve tayo ng collision, kailangan maging equal yung interchange no momentum, right? But since sobrang laki talaga ng momentum nito, hindi kayang i-counter no butterfly yung momentum nito. So that's why kapag ito gumanyan, madadala niya si butterfly. Okay? So hindi kayang i-counter no momentum ni butterfly yung momentum ni truck. Okay? Because of this equation. So later sa collision, may kita nyo rin yung conservation of linear momentum. Okay. Okay. So for an object, mass m moving at velocity v, we have these following equations: the linear momentum and the impulse, which is equal to the average force times the time interval, and is also equal to the change in the linear momentum. P2 minus P1, or final momentum minus initial momentum. Okay. Example. You throw a ball with a mass of 0.4 kilograms against a brick wall. It hits the wall moving horizontally to the left at 30 meters per second and rebounds horizontally to the right at 20 meters per second. Okay. Find the impulse of the net force on the ball during its collision with the wall. If the ball is in contact with the wall for 0.01 seconds, find the average horizontal force that the wall exerts on the ball during the impact. So before, ito ngayon, important ngayon yung before or initial saka yung final. Okay? So before nag-throw tayo ng ball, meron tayong V naught x, 30 meters per second. Negative siya kasi we assume that the eastward direction yung positive x. Okay? Yung mass, 0.4 kilograms. And then nag-bounce si ball. Nag-bounce si ball sa wall. Okay? So yung final state ngayon is it's moving to the right. So positive na ngayon yung velocity kasi doon natin sinet na yun yung positive x-axis. Or yung sa eastward yung positive x-axis. Okay? So first, find the impulse of the net force. So paano natin kukunin yung impulse? So may dalawa tayong formula. Right? J, remember, dalawa tayong formula for the impulse, force average, and then change in linear momentum. So, ang pinakamadaling i-apply to find the impulse is, for this problem, is yung second one. Bakit? Kasi alam natin yung mass. Alam natin yung V for both initial and final state. So, gagamitan na natin ngayon si J equals delta P. Magnitude-wise, so ito hindi vectors. So, magnitude-wise, it will just be P2 minus P1. Bakit? Kasi one dimension lang naman. Okay? So, hindi na natin kailangan yung I hat kasi x direction lang naman siya. So, it will be M. So, P2 is M V2x minus M V1x. Right? So, lalabas si M. So, meron ka na lang V2 minus V1. Okay. Which will be 0.4 times 20 minus yung magnitude, which is negative 30 meters per second. And so, ang impulse natin will be 20 kilograms meters per second. Okay. So again, ito yung ginamit natin formula, yung delta P. Yung delta P. Kasi alam na natin yung, madali lang kuhanin yung linear momentum. Okay. Now, the next question, find the net force. So, madali na lang yung net force. Bakit? Kasi alam na natin yung impulse. So, pwede natin gamitin yung second equation, F delta T. Okay. So, now, the average force or the net force is just J over delta time. Which is now 2,000 kilogram meters per second squared. Okay. I think dapat given yung time. Given ba dapat? Nakalimutan yata sa problem. Ayun pala, if the ball is in contact with the wall for 0.01 seconds, find the average horizontal force. Okay. Tinanggal dito. So, 0.01 given yung delta T. So, plug and play na lang. Okay. Or 2,000 newtons. So, force is in newtons. So, kilogram meter per second squared, yan yung SI unit for the newtons. Okay. Another example, a soccer ball has a mass of 0.4 kilograms. Initially, it is moving at 20 meters per second, but then it is kicked. After the kick, okay, so before, merong, the ball is moving 20 meters per second. Okay. So ito, before, yung ball mo moving here in this direction, 20 meters per second. After the kick, the ball moves now at a 45 degrees upward and to the right with a speed of 30 meters per second. Now we are asked to find the impulse and the net force. Average net force, assuming the collision time delta T is 0.01 seconds. Okay. So ngayon, medyo 2D na yung, two-dimensional na yung problem. Right? So important na ngayon yung direction. Right? Vector form na tayo. So V1, if we set our coordinate axis to be here, positive x right sa eastward and positive y sa upward direction, then yung V1 natin is negative 20 I hat. Right? Meters per second kasi pakaliwa. V2 will be two components, an x hat and a y hat, or I hat and a j hat direction. So that's V2, right? Is V2 x I hat plus V2 y j hat. Again, V2x, ito yon. So ito yung V2 mo. This is the V2x component. Ito yan. Yun nandito. Tapos ito yung y component. V2y. And alam mo yung angle which is theta. So again, using SOHCAHTOA, V2x, cosine theta equals adjacent V2x over hypotenuse V2. So that's why V2x is, okay, now find V2x to be V2 cosine theta. Okay. So ito yung I hat direction. So ngayon, yung V2y naman, siya yung V2 sine theta. That's why we have this sine theta. And again, V2. So V2, parehas lang ng V2 yan, yung magnitude. So lalabas lang si V2. And you have this inside as a vector form. Okay. So cosine 45 and sine 45, that's just both square root of 2 over 2. And then yung over 2 lalabas, so magiging 50. Okay. Now, to find the impulse. So ngayon, two-dimensional na. So we have the change in the linear momentum. So P final or P2 is yung this one. So that's mv2 minus yung P1 which is mv1. Yung mass ng ball hindi naman magbabago, right? So same lang yung mass. So pwedeng lumabas ngayon yung mass. And then you have V2, this one, minus V1 which is negative 20 I hat. And now, addition of vector form, components na lang. So meron kang 15 square root of 2 plus 20. Pero yung 15 square root of 2 na j hat hindi magbabago. So you will have this for your impulse. For the average net force, so paano nga yung average net force? Okay. So meron ka namang j over delta t. Right? So if you plug in j over delta t, mag-divide ka lang ng 0.01 seconds, then you get this as your average net force. Again, you can find, pag tinanap ay magnitude ng force, so magnitude ng force, so equal to sa square root. Remember yung distance, parang distance formula lang siya, or Pythagorean theorem. 1,650 squared plus 850 squared. Okay. So kung naman lalabas sa calcu, yun yung magnitude of the average net force. Ano naman ito? Okay. So ito yung vector form ng force. Pag sinabi magnitude, kailangan yung gawin ito. Okay. Okay. So with that, medyo mahaba and sana instructive yung mga examples and exercises. Okay. And if nahirapan kayo to grasp yung potential energies ng gravitational and elastic, just try out more problems. And again, open naman kami, your instructors, for consultation kung nahirapan kayo to solve some practice problems. Right? Kung mayroon kayong gustong practice problem na ipasolve na hindi FQ, pwede rin namang FQ. I mean, if you need more hints or you need more discussion regarding the FQ, andito rin. Pwede naman kaming mag-discuss. Okay. So that's it for our lectures for this week. Thank you and good luck.